Hey guys, this is Professor Janacek, and I want to go over some examples of using the chain rule for derivatives. Remember, the chain rule works on a composition of functions if you're taking the derivative of a composition. In this case, f is my outside function, g is my inside function. We start by taking the derivative of that outside function f, keeping the inside function as is, and then we multiply that by the derivative of the inside function g. So let's try an example or several. Example 1 here, we have y is 5x plus 4 raised to the third power. Now we want to take dy dx of this. Notice my outside function is 3. So in this composition, cubed would be the outside function. The inside function is that 5x plus 4. So dy dx, we'll start with the cube function. Derivative of that, we'll use the power rule, so that 3 comes to the front. Notice that inside function stays as is. Don't change anything about that. But the exponent gets reduced by 1. Then we're going to multiply this by the derivative of that inside function. I'm just making note of what we're going to do in the next step. All right, so let's go ahead and do that now. So that first bit, all is the same. And then if we take the derivative, if I actually evaluate that derivative, 5x plus 4, we end up with just 5. So we can combine those coefficients, put them all together, we get 15 times 5x plus 4 to the second power. All right, that wasn't so bad. Let's take a look at example 2. We've got y is equal to sine cubed of x. Might be easier to think of this one as sine of x to the third power. Now you can see sine of x is my inside function. The cubed function is the outside function. So just like the example before, if we want to calculate dy dx, we'll take 3 times the sine of x squared. Again, there's the power rule on the outside. And then we're going to multiply that by the derivative of the inside. Well, let's go ahead and work that. I was just writing down what we're going to do, but we can go ahead and do that work. So we have 3 sine of x to the second power. Then the derivative of sine is cosine x. So all in all, we have 3 sine squared x cosine of x. All right, not so bad. Let's take a look here at example 3. Y is equal to sine of x cubed. Notice this differs from the previous problem. In this case, we have the sine of x, and then my argument is x cubed. So here it's turned around from the last one. I still have a cubed function, but that's the inside function. My outside function is sine. So we're going to start by taking the derivative of that outside function. Well, the derivative of sine is cosine, but we're going to keep that x cubed on the inside of that. And then we're going to multiply by the derivative of that inside bit. So again, I'm just writing down what we're going to do, but let's go ahead and see if we can do that. So we still have cosine of x cubed but now we're going to multiply by the derivative of x cubed. The derivative of x cubed is 3x squared. Now, so this doesn't get too confusing, I'm going to go ahead and put this 3x squared in front as the coefficient. And so we have 3x squared times the cosine of x cubed. There we go. All right, example 4, we're taking the derivative of 6x cubed plus 3x plus 1 raised to the 10th power. So you'll notice the outside function is that to the 10th power. So taking the derivative of that, I have 10. Keep this inside stuff as is, don't change it yet. Power rule says I reduce that exponent by 1. And now I'm going to multiply by the derivative of the inside. You'll notice on the previous examples, I always wrote down what I was going to do. I'm hoping that you won't always have to write that down, so I'm not going to write it down on these next few examples. So we're going to just dive right in and now take the derivative of the inside function, which gives us 18x squared plus 3. Now, I do notice that I have a GCF here. I can factor out a 3 from that polynomial in the back, and I'll go ahead and multiply that with that coefficient in the front. So I end up with 30 times 6x squared plus 1 times 6x cubed plus 3x plus 1 raised to the 9th power. And there we go. All right, let's take a look at example 5 here. We're taking the derivative of the square root of 5x squared plus 1. Well, first, let me rewrite this. A square root, I know, is the same as a 1/2 power. That's going to allow me to use the power rule. So again, the outside function is that square root, or the 1/2 power. So I will take that 1/2 to the front, leave the inside function as is, reduce that exponent by 1. Remember, that's the power rule. Subtract 1 off of that. Exponent gives me a negative 1/2. Then, here's our chain. We have to remember to take the derivative of the inside. The inside here is that 5x squared plus 1. The derivative of that is 10x. Now this we can definitely simplify. I can reduce the 10 and the 2. That gives us 5x. And then this negative 1/2 power means it's a square root, but it's also negative, so that means it's really in the denominator. So this is 5x over the square root of 5x squared plus 1. Now make sure you know how to rationalize this. If you rationalize it, you'll get 5x times the square root of 5x squared plus 1 over 5x squared plus 1. So don't forget how to rationalize. In this case, we're rationalizing the denominator. All right, on to number 6 now. Oops. We're going to take the derivative d dt, notice our variable is t now, of 5t squared over 3t plus 2. All of that is raised to the 3rd power. So I see that my outside function is the cube function, my inside function. Ooh, looks like a quotient. All right, so let's see, what are we going to do? We'll begin by using the power rule 3 times. The inside stuff stays as it is. And then I reduce that power by 1. And then we have to take the derivative of this inside stuff. So the derivative, of this inside stuff, not sure what's going on with this whole neon yellow highlighter thing. Sorry, it's sticking around, not going away. Don't know how to get rid of it. All right, but anyway, so here we are, back to taking the derivative of the inside function. That is a quotient. Ooh, so we have to follow the quotient rule here. Quotient rule says we'll take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. All of this is over the denominator squared. All right, and absolutely this can be simplified, but you guys can do that. I'll let you simplify this. Take your time with it, but it should be something you can do, no problem. But hopefully you've got the chain rule part of that down. All right, let's take a look at example 7 now. d dx of tangent of x plus 10 raised to the 21st power. All right, so here My outside function is that exponent of 21. So we'll do 21 times tangent of x plus 10 raised to the 20th power. Then we multiply this by the derivative of the inside. The derivative of tangent of x is secant squared x. And there we go. Yes, you could move the things around if you wanted. It's really up to you. I will go ahead and just stop there on this one. All right, moving on to example 8. d dx of sine of e raised to the cosine of x. Oh my goodness. Looks like there's a lot going on here. Let's first think about what's what. The outside function is sine, so we'll just start there. So outside is sine, the derivative of sine, the derivative of sine. Okay, now something else is showing up. We'll see. All right, the derivative of sine is cosine. Keep the inside stuff as is. But then I'll write this one down just so everyone sees what's going on. Then I'm going to take the derivative of that inside stuff. Okay, so all this stuff is the same. Cosine of e, the cosine x. Now to take the derivative of this stuff inside here, notice my outside function is e. That's the only one I'm going to worry about. So the derivative of e is e. Keep the power, keep that inside stuff as is. And then we have to multiply by the derivative of the inside stuff yet again. So there's more inside stuff. So we had two chains here. All right, I think we are almost to the end of this. So we've got cosine of e to the cosine of x times e to the cosine of x times the derivative of the cosine of x, which is negative sine of x. All right, just to make this a little simpler, let's go ahead and move that negative sine of x to the front. And actually, I'll go ahead and put the e next. Ooh, there was a lot going on that one. Please take your time with that. Make sure you see all of those chains. We had to use the chain rule twice. All right, now to example 9. d dx of x squared times the square root of x squared plus 1. Well, just like before, I think it'll be helpful if we write this as x squared times x squared plus 1 to the 1/2 power. Well, it definitely looks like we're going to need to use the product rule. Product rule says we'll take the derivative of the first. Notice here the first is x squared and the second is x squared plus 1 to the 1/2. And that second part is where I'm going to need to use the chain rule. All right, so derivative of the first, that's 2x, times the second as is, plus the first times the derivative of the second. Okay, here's where the fun begins. Now we have to use the chain rule. So I'm taking the derivative of the second piece. That has a 1/2 power on the outside. So that chain is going to be 1/2 times, keep the inside as is, reduce that exponent by 1, 1/2 minus 1, negative 1/2, and then now we multiply by the derivative of the inside part. So inside there is x squared plus 1. So that derivative is 2x. All right, let's see if we can go ahead and simplify this a little bit. The first one is 2x times the square root of x squared plus 1. So that's just, again, that's just this piece right there. All right, that's not so bad. And then the second bit looks like I can reduce the 2 and the 1/2, and I can combine the x squared with the x, and then of course a negative exponent gets moved to the denominator, so that ends up being x cubed over the square root of x squared plus 1. All right, now from here, a couple of things you should be able to do. You should be able to combine these and rationalize. After doing all of this, so there's going to be quite a few steps in here, but I will let you have fun with this. I will, however, let you know what you should end up with. It should give you 3x cubed plus 2x times the square root of x squared plus 1 over x squared plus 1. That's what you should get. Take your time with it. Have fun with it. Enjoy!